Let's jump right into this explainer and figure out how to diagnose the hidden anatomy of your residential cooling system when it inevitably fails in the dead of summer. We all tend to take our air conditioning completely for granted, right up until the exact second it stops working. But this incredibly complex machine isn't just some magic box that spits out cold air. It's actually a living, breathing mechanical system. So today, we're going to peel back the metal casing and look at what is really going on in there. It is literally a homeowner's worst nightmare. You walk inside, you're sweating, you're expecting this blast of icy relief, and instead, you get hit with a sluggish, depressing breeze of warm air. Well, today, we're going to play diagnostic detectives to figure out exactly what your system is trying to tell you. Because every weird noise, every strange smell, and every tiny drop in performance is a clue. And we're going to decode the whole shebang together. We're essentially treating your AC like a patient today, moving logically through its bodily systems. Here is our agenda. 1. Diagnosing your summer AC. 2. Airflow issues and weak vents. 3. The cooling loop and coils. 4. Electrical and mechanical system failures. 5. Water leaks and high humidity. And finally, 6. Warning signs and professional safety. Okay, Section 1. Diagnosing your summer AC. Let's start our playbook with the absolute most important distinction you've got to make when troubleshooting. So here's the crucial thing. We have to separate the frustrating symptoms you are feeling from the actual root mechanical causes that are secretly spiking your energy bills. A symptom is the uncomfortably high indoor humidity, or maybe that terrifying grinding noise that wakes you up at 2 in the morning. But the root cause? That's what actually failed behind the scenes. We're talking clogged filters, low refrigerant, or blown electrical parts. Treating the symptom doesn't fix the machine. We've got to hunt down the root cause.
Moving on to Section 2, airflow issues and weak vents. Let's look at the system's lungs.
Just like us, if an AC unit can't breathe, nothing else works, and this sets off a terrifying domino effect. Step 1, a dirty filter restricts your airflow. Step 2, because that warm air isn't blowing over the indoor evaporator coil like it should, the coil literally drops below freezing and turns into a solid block of ice. Then, Step 3, your system strains so hard trying to pump refrigerant through that frozen blockage that your expensive outdoor compressor overheats and just dies. And that entire catastrophic failure can happen all because of a cheap $20 piece of pleated cardboard.
Think about how your sensory experience maps right back to the hardware. If you put your hand up to a vent and feel a weak, sad little breeze, you might actually be looking at a failing indoor blower motor, which obviously means really poor cooling. Or if one room feels like a meat locker and the other feels like a sauna, you're likely dealing with restricted air filters. And that just forces the system to work harder and skyrockets your energy bills.
Section 3, the cooling loop and coils. Let's examine the blood of the system, which is where the real heat transfer magic happens.
To really understand cooling failures, you have to realize that refrigerant travels in a closed loop between your indoor evaporator coil and your outdoor condenser coil. Think of it like a chemical sponge. It absorbs the heat from the air inside your living room, carries it through copper pipes out to your backyard, and wrings that heat out into the summer air. It doesn't actually create cold air, it actively removes the heat. But that closed loop is highly vulnerable. If dirt clogs up those coils, or say a tiny pinhole leak causes low refrigerant, the system entirely loses its ability to absorb and release heat. When the refrigerant drops, the pressure drops. That throws the whole thermodynamic balance out of whack, forcing your compressor to overwork, overheat, and eventually fail completely.
And here is a massive irony alert. It sounds completely ridiculous that a frozen evaporator coil happens during a heat wave, right? But ice buildup is a giant warning sign. If you open your utility closet in the middle of a 100-degree July day and see pipes encased in solid ice, no way should you celebrate. It actually means you have severely restricted airflow or a system-killing refrigerant leak. Your AC is essentially suffocating.
Section 4, electrical and mechanical system failures. Let's explore the brain and the muscle of your HVAC unit.
Have you ever heard your outside unit buzzing super loudly, but the fan on top isn't spinning at all? You are almost certainly looking at a failed capacitor. Think of the capacitor as a tiny, high-voltage powerhouse. Heavy-duty motors need a massive jolt of electricity to wake up from a dead stop, and the capacitor stores and delivers that crucial kickstart energy. When it fails, your motors just can't wake up, no matter how hard they try. So much odd system behavior is tied directly to electrical gremlins. Take short cycling. That's when your system constantly turns on and shuts off every few minutes. It is incredibly destructive to the machinery, and it's usually tied to a faulty thermostat giving bad commands or a dangerous electrical short. On the flip side, if it runs endlessly but your house stays warm, you might have tripped breakers cutting power to essential parts or loose electrical connections.
As a homeowner, you don't just feel an AC failure. You can actually hear it and smell it way before the cold air stops. A grinding noise? That points straight to failing motor bearings. Catch a harsh, acrid smell? That's often burning electrical wires. And if you smell something musty or dirty, that is a huge red flag for mold and dirt building up on your indoor coils. Truly, your senses are your first line of defense here.
All right, Section 5, water leaks and high humidity. Let's talk about how the system sweats, because a lot of folks forget that an air conditioner is also a massive dehumidifier.
When warm, humid air hits that icy cold indoor coil, water condenses on it, kind of like sweat on a cold glass of lemonade. Normally, this condensation drips into a pan and safely drains right outside your house. But if that condensate drain line gets clogged up with algae or dirt, all that trapped moisture backs up. It spills everywhere around your indoor unit, ruining your indoor humidity control and potentially causing thousands of dollars in water damage.
Section 6, warning signs and professional safety. This brings us to the most critical part of our diagnostic journey, knowing exactly where your DIY zone ends. Let me be crystal clear on this. Electrical, refrigerant, compressor, and internal mechanical problems should always be handled by a pro. It's non-negotiable. You should absolutely be checking and changing your own air filters every month, but you must never open electrical panels, mess with toxic refrigerants, or poke around moving mechanical parts. These systems use high-voltage electricity and pressurized chemicals. Always call a qualified technician for the internal stuff.
You might be wondering, why bother learning all these symptoms if we have to call a pro anyway? Because recognizing these visual and auditory warning signs early on is the ultimate secret to maintaining your system. If you catch a buzzing capacitor today, you prevent a totally fried compressor tomorrow. You stop artificially high electricity bills, and you guarantee you won't lose your AC during a dangerous heat wave.
And that brings us to our final thought for this explainer. By the time your system grinds to a complete halt on the absolute hottest day of the year, the severe mechanical damage is already done. So, the real question is, will you listen to what your AC is trying to tell you today through its airflow and noises, or will you wait for the expensive scream of total failure? Stay vigilant, check those filters, and stay cool out there.